how to build Instagram. Hey everyone, in this video we're going to be talking about how to build Instagram. So we're going to be going through a system design interview question. This is similar to the kinds of interview questions you might be asked at companies like Facebook, Google, Amazon, etc. And today we'll be going through sort of an example of one of these problems. I'll be giving sort of an example answer, as well as talking about some of the strategies and tips I would use to answer this question. So yeah, before we begin, what I would typically do is take a moment at the beginning of the interview to sort of really understand the question and the problem, and then go through some of the requirements and features that you think you'll need to be able to build. This is a good opportunity to brainstorm some features and think about the scale of your application. So let's imagine we're trying to build Instagram, we're trying to build sort of a reduced feature set, but we're trying to still think about scalability and building something that will work reliably. So yeah, let's talk about our requirements. So we are designing Instagram. Let's think about the requirements of our system. So let's say the first one is going to be that we need to be able to upload images from a mobile client, like a phone, iOS or Android. Our second requirement is going to be that we need to allow users to follow other users so that they can see content from other people. We'd also like to generate a news feed or sort of a feed of images and display that to users when they visit the app. And we maybe won't get into sort of a super complicated feed, but at least thinking about sort of the API to request that feed and how we would ensure that that is generated reliably. And then the last thing is we do want to think about scale. So let's imagine that we're working with or we want to design a system that's going to scale up to support 10 million users. Great. So these are our requirements. This is something I would sort of flesh out and discuss with the interviewer and make sure I understand sort of what each of these things means and sort of what their requirements would look like. So you could sort of dive into each of these things and get more specific around like, okay, well, what is a mobile client? Is that a native app or a mobile web? Do we need to support other platforms? Are we concerned about certain constraints like network or storage space on the device, things like that. Getting into the other ones, users following other users, we can get into sort of what that model looks like, which we will do. Generating a feed of images, we can talk about what is sort of the expected latency of getting the images, how often should it be updated or should the content be fresh, and does that include only people that you follow or some sort of explore feature? And then lastly, talking about scale, there's a lot we can get into here, and this is what we'll start with first. This is always something I like to do at the beginning of thinking about a design for a system is ultimately what sort of scale do we need our system to work at? So the first thing I would do is let's start with this 10 million number and let's break that down a little bit into what that actually means. So let's assume that we're talking about 10 million users who are using our service on a monthly basis and like 10 million active monthly users. And let's imagine that each of them is uploading 2 photos per month. That's how we define this active user. That's our average case that we're shooting for. And let's say that each of those photos is going to be around 5 megabytes. And let's allow that to sort of include some the metadata like the caption as well as the location and maybe some other photo metadata that we want to include. We'll ignore for now things like comments and other types of things we might need to store because that wasn't in sort of explicitly in our requirements, but that's something we could also think about later. So let's crunch these numbers a little bit. So 10 10 million is 10 to the 7 times 2 times 5 megabytes. So that's basically 10 to the 8. So that boils down to 100 million megabytes, which is 100 terabytes per month. So, times a year, we're going to be looking at 1.2 petabytes of data. So that's a lot of data. So obviously this is, and that's only going to grow over time. So this sort of doing this exercise sort of informs just how much traffic are we going to have, what are our storage requirements going to look like, and what sort of systems should we choose to support those. And so since we're talking about a lot of photo data here as well as metadata, we know that just sort of looking forward into our system, we're going to have to be thinking about different ways to store those types of data and how to do it in a way that's reliable and efficient. So let's look at that. The next thing I would do before we get into specific components of the system is I like to sort of take a step back and think about the API or the data model of our system. So in this case, let's start with the data model because I think we know clearly which things we need to store in this case. And then we can talk about the API a little bit later. So what I'm going to do is I'm going to just create, we know we have 3 different data types basically that we need to model. There's the users, there's the photos they're posting, and then there's sort of this user following model as well, where we need to store sort of this relationship between different users. So what I'm going to do is I'm going to sketch out those 3 sort of database tables. And I'll also talk about sort of the kinds of database I would choose for these different types of data. So let's look here first. Let's make this our user table. We'll make one for photos, and we'll also make one for followers. So yeah, let's talk about these for now, and let's save this for later. So the first thing I want to talk about is our choice of database. So we have a lot of choices here, and we have multiple kinds of data, so we can store things in different ways. This is what I view to be a fundamentally relational type of data problem, because we know we have clear types of data, users, photos, as well as a relational system between them. So we have users are related to other users in a many-to-many way by way of this following mechanism. So one user can follow many users can be followed by a user, and a user can be followed by many people. I think that might be the same thing I just said. On the other hand, we also have photos, which are related to users in a many-to-one way. So one photo can only have one user or owner, but a user can have many photos. And so there's this inherent sort of relationship between the kinds of data that we're trying to model. And that to me lends itself to a relational database. Obviously, we could also store things, and by relational database, I mean like a SQL database like MySQL or Postgres, or any others. There are other options, so we could also look at NoSQL databases. What I would suggest is that you think about whether your data is inherently relational and whether you would benefit from being able to do relational queries. In this case, I think being able to quickly get all of the photos for a particular user, that's a thing you would have to do on a very regular basis. that's an inherently sort of relational query pattern. And so I think choosing a SQL database in this sense makes perfect sense. And yeah, so I'm going to go with that. I'm going to go ahead and start modeling out these tables based on sort of the requirements we know we have of our system, and just sort of using common sense here of patterns I've seen before. So in the user table, we're going to have a primary ID, which is going to be our primary key. It's going to be an integer, and it's going to increment serially. This is just sort of SQL speak in terms of the schema of that of this table. So some other things we'll probably need for a user would be name, which would be a string. We're going to have probably an email address, which would also be a string. We're going to have perhaps like a location, perhaps some sort of other ID or other attributes about the person. So I'll go ahead and maybe just mention some of these things, maybe time zone, things like that. But these are sort of, I think, the basic things we need to get started here. For the photo table, we're also going to have an ID. This is going to be, again, our primary key. We're also going to have, in this case, we're going to have a foreign ID referencing the user. So this is going to be a foreign key referencing user.id. So that would be our relationship between these two tables. We're probably going to have a maybe a caption or description for this image, and then we might have additional metadata like the location it was stored, which might be a string or coordinate type. And then lastly, I mean, one thing we're going to have to do here is because of the large nature of these images, we're not going to store them in our database itself. We're going to just use this database to model the metadata about the images, about the users. So what we're going to also need here is some sort of path or URL, which is going to be a reference to our sort of distributed file system that's going to actually store and replicate and handle basically everything related to storing these files, these images. So that's sort of the basic building blocks of that, which is what we need. And then lastly, I'm going to talk about sort of the model for building followers. So in this case, it's actually pretty simple. We could actually just have two columns here. There's going to be user one, essentially, and user two. And these are both going to be foreign keys referencing one user and the other user. And what this table does essentially is it's just a relational table that models one direction of someone following. So user one can follow user two without user two following user one. So we might call this, in addition to calling this user one or user two, we could call this like, from and to sort of model this single direction relationship. This is a little bit different than Facebook, where friends are inherently bidirectional. So just something to keep in mind as you're thinking about this relationship. Great. Okay, so now we have sort of our basic data model in place. Let's talk a little bit about the overall system and the high-level components that we need to sort of bring all this stuff together. Keeping in mind the sort of scalability and requirements that we laid out at the beginning, as well as the features that we need to support, namely having users upload photos, having them be able to follow other users, and getting to see this news feed of images that have been posted by their followers. Moving on to that, let's talk about each of these components. So At a fundamental level, I'm going to start with the database since that's what we were just talking about. So this is going to be our metadata database. In addition, one of the important pieces here is this idea of the image paths that we're storing in the photo table and where those are going to be stored. So we're also going to have in a distributed object storage mechanism, and this is something like S3. So we'll leave this a little abstract, but basically what we want to do is use a distributed file system like S3 that's going to store and replicate our data in a reliable way. And then we're going to store the reference paths to files that are stored there in our metadata database. And that way we can have a separate reliable place to upload images and reference them that will be accessible and fast. And there's a few ways we can sort of improve the efficiency of this, which we'll get into in just a moment. But essentially, there's sort of this connection between these two in this way. All right, so next what we'll be talking about is our application service layer. So we haven't gotten into this yet, but this is going to be the actual sort of core of our system. These are going to be the servers that are responsible for the so-called like CRUD operations, create, read, update, and delete. So this is what sort of serves as the system that's going to be responding to requests from clients, whether mobile or web, or et cetera, and are going to be handling those and then performing operations on the database or getting information and returning it to the user. So this is really the core part of any web backend system. It's going to be often many different kinds of servers for one of these large applications. Typically, the pattern is to start with a monolithic architecture where you build a web app that responds to all the different types of requests that are coming in. And then over time, as your traffic scales up and you find different patterns of usage or different query patterns that are more popular than other ones, or different kinds of requests like operations that have to happen asynchronously or that take a long time to calculate, you begin to start splitting up this monolith into different services or microservices that perform specific operations and can be scaled independently of one another to optimize your server usage. So let's think a little bit about the access patterns that are probably going to happen in an Instagram-like application when we reach the scale of 10 million users. What we expect to happen here is there's going to be a lot more people viewing and reading their feed than there are going to be people uploading. And we need to be able to do both those operations efficiently and support maybe different sort of access patterns that are happening at different peak times of the day. You know, there's all these different sort of usage patterns that we need to be aware of that might affect the way we build our system. So knowing that this is sort of a read-heavy system, we're going to want to have probably not just one one database here. We're going to want to have replicas of this, read replicas of this database that will allow us to efficiently read data from them without essentially slowing down our ability to also write data and upload new images. And this will allow us to achieve a higher scalability of our system and just overall like a larger throughput of request volume, since the database and the connections to it are often one of the major bottlenecks of any system. So we're going to go ahead and build our application server here. And what I'd like to do is split this into maybe two different services. So let's think about like the read services and the writing or uploading services separately. Since, as I mentioned, they might have different patterns, different requirements. They might require different types of caching and other things. So for example, our read, we might implement caching here in between the database and the app server, like in in-memory storage like Redis. This would allow us to return frequently accessed data much faster than making a request to the database every single time. So yeah, let's draw a cache here. I'm actually going to move these over a little bit so that I can draw this cache in between them. And let's just mention that we're going to read from the cache here. And then on our write service, we're going to write to the database, and we're also going to update our cache in the process. Now, there are several different caching policies, and I won't get into all the different ways in which that works, but essentially we want to use sort of a write through or write back policy where when a write behavior or an update happens on some content that's in our database, we want to update our cache at the same time so that downstream the read service that's using this cache to return data to users is updated in a reasonable time and is consistent with the sort of source of truth in our main database. So I'm sort of just drawing these arrows here to represent these relationships, but there's multiple ways in which this update could happen, and ways in which these sort of things would be triggered and implemented in reality. I'm just going to note that like this would probably be some sort of distributed cache system like Redis that would be really performant and sort of sit separately from our main database. So, all right, so now we have two different services here that are responsible for different parts of our feature set. One is responsible for fetching images and returning data to the user. The other is responsible for performing this sort of upgrade, this upload process, which would also not only send data into our metadata database, but also would handle actually uploading the image from the client to the file storage system. All right, so now we're beginning to get a sense of what the system would look like. So sort of moving up the stack a little bit. So we're also going to need to have a load balancer. So as any system scales, becomes very important that the sort of fundamental pieces of the system can support the load and volume requirements of the number of users that are attempting to use it, because otherwise you'll begin dropping requests or taking really long time to serve users as the requests sort of queue up. One of the most common patterns of solving this sort of problem, or solving some of these problems, is to scale horizontally. So what we would do is we would not have just one app server for reading and writing. We would have many servers, perhaps located in different access points throughout the world, depending on how large our application is. And we would serve requests to these servers in sort of a load balanced way, so that each one is sort of utilized equally with the others as much as possible so that no one server becomes too overloaded or too overworked to the point where it begins dropping requests. So this is the responsibility of a load balancer. It can also handle, there could be a separate load balancer or a separate router to handle sending requests to the correct application server. For simplicity, let's just sort of imagine that it's one sort of proxy here that's doing both load balancing and routing. Let's talk about how our client is going to be making this request. So again, we'll probably have a variety of mobile clients who will be reaching our server through the internet and sending requests that could be getting images, could be uploading images. And so starting from the client, they'll call our API, which will have a different route for each of these sort of features that we want to support. Our request will come to our load balancer, which will be sort of the top level part of our system. It will get the request, it will figure out which service it belongs to, and we'll route it to that service or one of the instances of that service. And then it will, in the read case, it will figure out, does this user have, it will do all the sort of business logic of figuring out, what image am I looking for? Does this user have access to this image or is it private? It will look to the cache first to see if it has this image in there. And if the cache is, fresh, it will just return the image. It will return the image data or any user metadata that it needs. That response would come all the way back through, get returned to the mobile client, and would then include the path to the image that needs to be loaded. That request would probably be fired off separately and would then be loaded in a separate request from our distributed file system. And then sort of sitting in between here, we might have a CDN or some sort of distribution network that would make these requests faster by having basically access points in different parts that are sort of closer and make the sort of last mile request latency much faster. In the upload case, when a user is creating a new image, something similar would happen where we would open a connection to the server. It would begin to, would upload all the metadata related to user and the photo that we're uploading, and then it would handle receiving that image and passing it on into the object storage. As we mentioned, that process would also cause the cache to be uploaded so that new content could be available to users who are making requests. And that's basically it. So the one thing we haven't talked about here is the process by which we would generate sort of a feed of images for each user. And the way I would think about that is that could in fact be a process that happens and also gets stored in either this cache or another feed cache. And that process could be managed by this read server or by a separate service. Let's call it let's call it the feed generation service. This service would access our cache as well as our database. And this would be operating, perhaps depending on the requirements of the feed that we want, would be operating on a schedule perhaps generating a new feed for each user on like an hourly basis. Um, and yeah, would talk to the database, understand which content was new, and would sort of generate these things, which typically would be too computationally intensive to do on the fly for every request. And instead, we can do it ahead of time, pre-compute these feeds, store them in our cache, and then allow the app server that's responsible for getting the feed to then just read the cached results. That's basically how that would work. All right. There's obviously a lot more detail we could go into on every single part of the system. We covered a lot of ground here and talked about a lot of different components. But this is sort of the overall system that I would design for Instagram. And yeah, if you have any thoughts or questions, please leave a comment. And we look forward to making more videos like this if they're helpful.